Good evening, everyone. I hope all of you are fine. Am I audible and visible to all of you?
Yes.
Yes. Who said this? Kaushiki. Okay. Are you okay, Kaushiki? Your voice looking a bit dim.
Hi. Yeah, I'm okay. Thank you.
Okay. Chalo. Tell me what we were doing in the last class. What was the topic of discussion in the last class? Vedansh, Ayush, are you there? Or everyone?
Yes, sir.
क्या पढ़ रहे थे last class में? बताओ.
Sir, we have done some questions on displacement and distance.
We had done some questions on distance and displacement, right? Okay. एक और question just to rewind yourself what we were doing. Let me give you one more question. Ting ting ting. Okay, I can't make it from here, so I will just draw it like this. What is this? What is it that you see? Arey, what is this? It is a what? Semicircle. Do you know semicircle? Half of a circle. Arey, I'm audible or visible? Yes or no?
Yes, sir.
Okay, what is this? It's a semicircular track. Half of a circle. You understand circle? Radius r. You know circle? Yes or no?
Yes, sir.
All of you know what is a circle? Ayush, Vedansh, Kaushiki.
Yeah.
Yes, sir.
Do you also know what is the circumference of a circle? How
Yes,
much
sir.
is the circumference of
Yes,
a
sir.
circle? How much is that?
2 pi r.
2 pi r. Do we all know this? Vedansh, Ayush?
Yes, sir.
Okay. So now what
Yes,
is happening here? A particle has moved from point A to point B on a semicircular track. The question is very simple. Find out the distance traveled and the displacement of the particle. Now you would say, sir, the chapter that we are doing is motion in a straight line. This is not a question of a straight line. I will say, yes, beta, this is not a question of straight line, but whatever we have studied definitions of distance and displacement. And remember, these definitions are valid everywhere. चाहे वो motion in one dimension हो, whether it is motion in 2 dimension or it is general motion. Whatever definitions we have read are valid everywhere. Just to make this point, we are doing this question. A particle is moving on a semicircular track from point A to point B. Two questions I have asked. What is the distance traveled L and what is the displacement of the particle? Who will give me the answer? Vidansh, Ayush, कौन देने वाला है आंसर? कौशिकी.
So the distance is 1/2 times 2 times bar OR, and the displacement is vector AB.
What is the distance traveled? Remember.
So the circumference, but 1 times 1/2, so half of the circumference.
So the distance traveled will be, it is a semicircular track. So you have to find the length of this track. Ayush, how will you find the length of this track? Ayush, कैसे मिलेगा length of this track which is equal to the distance? Ayush, are you there? Can you hear me? वेदांश,
Yes, sir.
कैसे मिलेगा distance traveled? How will you get the distance traveled?
Sir, 2 pi r by 2.
2 pi r divided by 2. आयुष कैसे आया ये 2 pi r divided by 2? Ayush, are you there? I think he is not able to connect. 2 pi r है पूरे सर्कल का circumference. This is half of the circle. So it will be total circumference divided by 2 and the distance traveled will be equal to pi multiplied by r. You can just write it as pi into r. You don't have to put the values. The answer is this one. The distance traveled by the particle is the length of this path and it is equal to 2r. Do you understand this? If you understand it, just raise your hand so that I can see that you have understood this. Length of this path is the distance traveled by this particle and that is equal to pi times r. Raise your hands in the group so that I can see. Vidansh has raised hands, so he understands this. Kaushiki, do you understand this? Ayush, I think Ayush is there. Okay, he can't speak, but he understands. Okay, now we come to the dangerous part. In fact, from where I see, from what I understood for the so many years that I have been teaching, in any question, now you will get older, you will get into standard 11, 12, same things will be coming again to you back. Whenever in a question you are asked distance, that is always tough. The easier part at any time is to find out displacement. Because to find out the distance, you must calculate the length of the exact path. For that, you must know what the path is. If the path is simple, straight line or a circle or a triangle, you can even then find it out. But if it is zigzag, 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 zoom, it becomes very difficult to find out distance. But no matter what the distance is, no matter what the path is, displacement is always the easiest to get. Why it is the easiest to get, Kaushiki?
The displacement would just be AB vector.
It is simply you just start a vector from A and you make the vector AB. How do I change this line? I'm now never able to make this line correctly. I don't know why. I try, but I don't start from the same point. I don't know why. Let me try it again. Okay, this is better. So to find out the displacement, I got to do nothing. Just draw a straight line connecting A and B. And in fact, I can very easily write this displacement is equal to this AB vector. But you'll have to find the answer. You will have to tell me when you write this AB vector, what are two things that I need to know? One is the magnitude and other one is the direction. Who will tell me the direction first?
Sir, east.
You don't have to see Ayush, see Vedansh. The thing is, you don't say east unless the question is given in north, south, east, west. You never know what is the direction. You never know. You don't say east. Don't say west unless and until someone has told you ki bhai, this is north, this is south, this is east, this is west. Then only you talk in terms of direction. Here the direction is not given. Which is north, which is south. I can very well call this as north, this as south. Then this will become west and this will become east. So now it is not. Are you getting my point, Vedansh?
Yes, sir.
So you can't say direction like this unless direction is given to you. I can simply say the direction as the direction is from
A to B.
A to B. That doesn't change. Wherever is A to wherever is B, direction is from A to B. Now what is remaining is the magnitude. So you just have to tell me the length of this line, and length of this line will be the magnitude. And what will be the magnitude of length of this line? This is nothing but the diameter of this circle. Yes or no?
Yes, sir.
What will be the length of the diameter of the circle, Kaushiki?
2r.
2r. And that is your answer. The magnitude is 2r and the direction is from A to B. Do we all understand this? If you understand this, please raise your hands. As I always tell each and every kid, the easiest thing in this chapter is always to find out displacement, because it is a straight line always, joining the initial point to the final point always. Distance is what that will create trouble. Chalo. Now, just to be more adventurous and expecting a lot from you, you are small kids, but it's, no limit to human expectations. I'm again putting one more question here, which I was not planning to do, but since you have understood what have we discussed up till here, I get a point B here. Okay, there was a point B, which was the end of the diameter. Now I also get a point C somewhere in between. Now I can put up this question from A to C. Please remember, please listen to the question carefully. I hope you can all see the point. See, whatever we have done up till now, was the answer for the question from A to B. We have taken the entire journey. Now, listen to the question carefully. I have changed the question and now I am putting the question like this, like what? From A to C. From A to C, what is my distance traveled and what is my displacement? Please listen to the question carefully. From A to C, I'm only concerned about, I'm not concerned about the entire path. I'm only concerned about the path from A to C. What is the distance traveled and what is the displacement? Now you can see both of this. Look at the point A. This is the gentleman A. This is the gentleman C. From A to C, if you can look it here, I've made it in blue. I like coloring, so I colored the entire rectangle. From A to C, what is the distance and what is the displacement? Who will tell me this? A to C. A to C. Toshiki, Ayush, Vedansh.
Sir, distance is 2 pi r by 4.
Distance is 2 pi r by 4. Very nice. What is the displacement? You have done the tough part. Now do the easier part. Kaushiki, any idea what will be the displacement?
Yeah, so root of r square plus r square.
So how much is root of r square plus r square?
We don't know what r is.
You don't know, you know it, but you don't know that you know it. Okay, don't worry. That is why I'm here, to let you know that you know it, and you should have that much confidence that you can do it. Now let me draw that part once again, because it's not possible for me to go up. This is the part that we are talking about, A to C. This was our center. Remember, the distance from here to here is r. The distance from here to here is r. Do we all agree on this? Can I have raised hands that we agree on this, sir? Both are r and r. Now, once we talk about the distance traveled, now this is, as you can see, 1/4 or quarter of a circle. 1/4 or quarter of a circle. So the distance traveled will be 1/4 of the circumference. Total circumference is 2 pi r. This is 1/4 of the circumference, half of half, quarter of a circle. And the tough answer is pi r by 2. That is the distance traveled by this particle. Vedansh, Ayush, Kaushiki, can I have raised hands that we understand this? The tough part, distance traveled is 2 pi r by 4. 2 pi r is the circumference. It is 1/4 of the circumference. So it has to be pi r by 2. Ayush, did you get it, beta? I don't see your hand. Yes. Okay, everyone got this. Now let us come to the easier part. What is easier part? I have to find the displacement. I start from A and I just draw this line, this vector. So without any fuss, I can write delta R, the displacement vector, is simply AC vector, and your answer would be perfectly all right. But I need the magnitude and the direction so that I understand it. Who will tell me the magnitude and direction? The easier part probably is the direction. So what is the direction? Direction is as usual A to C. Just write the direction of A to C. Magnitude, how do you find the magnitude? To find the magnitude, beta, you just have to find the length of this line. Now, if you look very closely on this line, very closely, does this diagram remind you of something? Ashiki, what does it remind you of?
Yeah, I said a right angle triangle.
Ayush, does it remind you of a right angle triangle? This becomes your base. This becomes your perpendicular. And this becomes your hypotenuse. Everyone knows that hypotenuse square is perpendicular square plus base square. Perpendicular is r, so this is r square plus r square is hypotenuse square. And move ahead. So I write hypotenuse as under root of 2r square. R square plus r square becomes 2r square. Kaushiki, are you following me?
Yes.
How do I find the square root of 2r square? I first find the square root of r square. That will be r, that comes out. So the length of the hypotenuse becomes r. And then I have inside the root 2. So it becomes r root 2, or you can write it as root 2 times of r. Do we understand this? And I put it simply here. This is root 2 times r. Do we understand this? All three of us. And I have raised hand that we understand this, sir. This is root 2r, r square plus r square under root. Vedansh has understood this. What about Ayush and Kaushiki? Ayush follows it. Kaushiki, still doubt? So that is probably the most difficult question that can be made at your level. I doubt that many students will be able to do this. Even in 11th standard, some students are not able to understand this because in their head they have made this notion that displacement is shortest distance. Remember, displacement has got nothing to do with distance. Displacement is a vector. It is change in position vector. Displacement is a vector. It has magnitude and direction. Distance is a scalar. It is length of the path. One is length of path. One is change in position vector. Both are entirely different. Whenever you talk about displacement, always talk about its magnitude, but never forget to talk about its direction, because if you lose the direction, you will lose the sense of vector, and then this vector is going to make your life very, 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 very tough. Don't forget this notion. On this note, we can say bye-bye to distance and displacement. We have covered almost everything that was possible here. Almost everything that was possible here. Even up till 12th standard, we have covered almost everything. What is the next thing that you must understand? Anyone has any idea? I think all of you have done this chapter, so you must be knowing what is ahead. What is the next thing ahead?
Sir, speed and velocity.
Sir, speed and velocity. So let us tackle speed first. What do you mean by speed? What do you mean by speed? Who will tell me the definition of speed?
Sir, the distance traveled by a body in unit time interval is called its.
Okay, this is a good definition of speed. It is the distance traveled by a body in a unit time. It's correct. No problems with this one. Let me see. Where is your sheet? Here. What is given in your sheet? Ting, 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 ting. Okay. So, speed. Distance traveled by a body in unit time. Or I can call this as rate at which distance is traveled with time. Do we all know this definition? The rate at which a body covers distance with time or distance traveled by a body in a unit time is known as speed. What are the important points you must remember? The first point is definitely it is distance traveled in unit time. Number two, what type of quantity is
Sir,
speed?
scalar quantity.
Shabash. Speed is a scalar quantity. So it only has
Magnitude.
Magnitude.
It only has magnitude. Well done. Point number two. What is the SI unit?
Meter per second.
Meter per second.
Well done. Meter per second. There is one more unit that we commonly use, and the commonly used unit is kilometer per hour. How do you convert it? I will let you know. Just give me time. Let us first note the important points about this. I hope you are writing. Number three. Now see, speed. It is the rate at which body covers distance. Can a body cover negative distance with time? Can a body cover negative distance with time?
Not yet, no.
No, it cannot cover negative distance with time, and hence what?
Positive quantity.
It is always treated as positive. It is always treated as positive. Will you remember this? Yes or no?
Yes, sir.
Pakka?
Yes.
Okay. Three things that you must remember about speed. Now, there are some commonly used units of speed. Let us try to do a little bit on this. What are the commonly used units? Number one, meter per second, which is the SI unit. Number two, centimeter per second. which is the CGS unit. I told you, na, MKS system, CGS system. Do you remember it?
Yes, sir.
Third one, which is also used, is kilometer per hour. Kilometer per hour. Now, what type of question can you expect from here? What type of question can you expect from here? You can expect questions of this type. Conversion of what? Conversion of speed from one unit to the other unit. Conversion of speed from one unit to the other unit. How will you do it? Without telling you anything, I put up a question. Question number 1. Convert. Let's see how much you know. Convert 5 meter per second into centimeter per second. Let's see if you can do this. Who thinks that he can or she can do it?
Yeah.
Kaushiki always thinks that she can do it. Yes, Kaushiki, tell me how you'll do it.
500 centimeters per second.
500 centimeters per second. How did you get it?
Because the seconds is the same, so you just convert meters to centimeters. 1 meter is 100 centimeter. So
Done. That is what we were looking for exactly. Vedansh, Ayush, any idea what she was talking about? Vedansh,
Yes, sir.
Ayush, कैसे होगा? Okay, so 5 meter per second I have on this side, and I have to convert it into centimeter per second. It's very simple. So just write it like this: 5 meter per second means it is divided by second. I convert it into centimeter divided by second. So basically, what I need to do, I need to convert meter into
Centimeter.
and second into second. Second into second is second only. And 5 into, I can't convert 5. So what do? I will write 5. जैसे का जैसा, ऐसे को वैसा, वैसे को वैसा. 5 की जगह 5. And meter की जगह I have to convert it into centimeter. How will I convert meter into centimeter?
Multiplied by 100.
That's it. And so the answer is 500 centimeters per second. Do we understand this? Ayush understands this. Vedansh, Kaushiki? Kaushiki, Vedansh, Ayush, all of you understand it. It's pretty simple. Don't have to do any magic trick. Very simple. You can do it in simple ways. Will you be able to do the next one that I'm going to give you? Confident? Okay, this is the next question. Question number 2. Convert 250 centimeters per second into meters per second. I've just reversed the question, nothing else.
2.5 meters per second.
Shabash, Vedant. Ayush, what about you? Ayush, are you there, Bacha? Kaushiki, did you get it?
Yeah.
Ayush, your mic is not working. Okay, you can type. Did you get the answer? Simple. What you got to do is you got to do it. Okay. You don't have to be sorry for mic not working. You can't do anything about it. So basically what I have is here 250 centimeter divided by seconds, converted into meters divided by seconds. Centimeter goes into meter. So either you can divide it by 100 or multiply it by 10 raised to the power minus 2, whatever you feel comfortable. Second goes into seconds, same. 250 goes into 250, so I'll just write 250. 250 centimeter into meter, so just divide it by 100. We have the answer 2.5 meters per second. Quickly raise your hand so that I can move forward with the next conversion. Vidansh has raised his hand, waiting for Ayush and Kaushiki.
Yeah, I get it.
Okay, Ayush. Got it? Ayush, can you raise your hands? Okay, done. Let us move on to a somewhat difficult one. Nothing is difficult in this universe. If you understand things, everything becomes simple. Convert 18 meter per second into kilometer per hour. Now you will say why 18? There's a reason why 18. (18 meter per second into kilometer per hour. I should say not 18. I made a mistake. It should be 5 meter per second. That would be better. It should be 5. Sorry about 18. 5 meter per second. Anyone, any idea? Okay, I'll just give you a brief on to converting meter per second into kilometer per hour. So what you got to do here is convert meter into kilometer. To convert meter into kilometer, what do you do?
Divide it by 1,000.
You divide it by 1,000. Then you convert second into hour. Oops, wrong color. Then you convert second into hour. Remember, second is in the denominator. So second into hour, if you have to convert, you will divide it by 3,600, yes or no? So you have to
Yes.
go into denominator and divide it by 3,600. So basically this 3,600 comes on in the numerator. I can cut these things up and I am there with an answer 18 by 5 kilometer per hour. You can remember this. If you can't remember this, you can always find it out. So the relation that I get is this one, 1 meter per second is equal to 18 by 5 kilometer per hour, and you can use this to convert meter per second into kilometer per hour. Do we understand this?
Yeah.
Can I have raised hands from all of you? Okay, Ayush and Vedansh have raised hands. Okay, now if I want to do the reverse of this, can you tell me what will be the reverse of this? I have to convert kilometer per hour into meter per second. Who will tell me the reverse equation? The reverse equation will have 1 kilometer per hour is how much in meter per second? The reverse equation. Kaushiki, tell me.
Wouldn't it just be 5/18?
5/18 meter per second. That is exactly correct. Well done. Do we all understand this?
Yes, sir.
Yes, sir. No, sir. You have to still solve the question, sir. Convert 5 meter per second into kilometer per hour. And what is your answer for this one? 5 meter per second into kilometer per hour. So what will be the answer? 5 meter per second. How much in kilometer per hour? Waiting for your answers, gentlemen and ladies. Kaushiki, what is your answer?
So 18.
No answer?
So,
Ayush? Vedansh?
I
Yes,
said
Kaushik.
18.
Answer
18
is
kilometers per hour.
18 kilometer per hour. That is correct. Absolutely correct. आयुष वेदांत समझ में आया कैसे आया?
Yes, sir.
1 meter per second is 18 by 5. So how much is 5? Just multiply it by 5 and your answer becomes 18 by 5 multiplied by 5, which is simply 18 kilometer per hour. That is the answer that we were looking at. I hope you have understood this. Please, all of you raise hands so that I can move forward with the next and the last conversion in this category. We can't waste much time on conversions. We will have to move ahead in life. And to move ahead in life, I'm using the wrong pen. To move ahead in life, we will do this question. 54 kilometer per hour is to be converted into meter per second. And let's see who gives me the answer first.
Sir, 15 meter per second.
Well done. Vedansh, तेरी आवाज है ना ये?
Yes, sir.
Yes, Vedansh, that is correct. Ayush, got your answer, beta? Kaushiki, got your answer?
Yeah.
Everyone got their answers. So what you got to do is just remember how much is 1 kilometer per hour. 1 kilometer per hour, as you can see, is simply 5 by 18 meter per second. So how much is 54? 54 would be simply 5 by 18 multiplied by 54, ting ting, 3 times, and the answer would be 15 meters per second. That was the conversion wala part. Every one of us understands this. Can we move forward in our journey? Can we
Yes,
move
sir.
forward? Yes, sir. Yes, sir. Now we come to the part where what? We have to understand the different types of speed. Different types of speed. Now, before launching ourselves into orbit for the different types of speed, may I know whether you have any idea about or you have heard about any type of speed? Or have any idea? Kaushiki, Ayush cannot speak, but he can obviously write. Kaushiki, Vedansh, and Ayush on the, let's say, keypad, QWERTY keyboard. Any idea about the types of speed?
Like
Like,
very fast, very slow.
yeah, good one, very fast, very slow. No, that is not the one we are talking about. Let's think about something else, not very fast. A uniform speed, Ayush has come up with a very nice term. So now, will that term give any idea to Kaushiki and Vedansh? He said uniform speed. Does that give you any idea about any other type of speed?
Constant speed.
Constant speed. Kaushiki, does constant and uniform not mean the same thing?
Sir, equal distance in equal time.
That is, isn't it same as uniform speed? Isn't uniform and constant mean the same thing? Kaushiki?
What about relative speed?
Relative speed. Okay, I give you that one. Relative speed, I never thought about it, but I'll give you that one. Anything else? From uniform speed, just do the opposite of this, right? You know, you must have played opposite.
Sir,
Even
non-uniform.
speed. Even speed. What do you mean by even speed? Ayush is giving me formula for even speed. A thing is said to be at even speed when it is not even speed, beta. Same distance in equal intervals of time. That is not even speed. It is not known as even speed. You're just confused. Yes, Vedansh, you were saying something.
Sir,
Clear.
non-uniform.
Non-uniform speed. Yes. If one is uniform, the other one has to be non-uniform. Kaushiki, see, that is what you call logic.
Varied or changeable speed.
Yeah. So now you are trying to give the same speed different names. Variable speed is non-uniform speed. Changing speed is non-uniform speed. So it is the same thing that Vedansh has talked about. Let us start with the types of speed, and you would be very fascinated to see the first type of speed. And this is known as average speed. Average speed. Average speed. Ever heard this term, average speed?
Yeah.
Yes. See, congratulations. So tell me, what is it?
When something moves at different speeds in a long period of time, so you calculate the average speed. Like a car. So if
Give
it's
me an
moving,
example. Okay, I'll try to understand with your example. Give me an example of average speed.
so like a car, in the first like 30 minutes, it's moving at like 20 kilometers per hour. And then the second 10 minutes is moving at like 30 kilometers per hour. And then last 10 minutes is also moving at 20 kilometers per hour. So the average speed would be 25 kilometers per hour.
How did you get the average speed, beta?
So it was 30 for half and then 20 for half.
So it becomes 25. No, it does not become 25. You're given the right example though. Yes.
So it's the total distance traveled by the time taken to get to that distance.
Yes, that is what you mean by average speed. To find out the average speed, what you do? You find out the total distance. You find out the total distance, what you have traveled, and just simply divide it by total time. That is your average speed. Do we understand this? In terms of alphabets, I will write it as L by T. L standing for
Distance.
total distance. T standing for
Time.
total time. Now, Kaushiki gave an example, but I'll give you another one on similar lines. Vedansh goes from, hey, have your school started at offline schools? Vedansh,
Yes, sir.
what is the timing? Are you going to daily?
No, sir. It's very far from my home.
So you don't go?
No, sir.
Well done. What about you, Kaushiki?
So face-to-face school started.
Are you going there? How many
Yeah.
time? How many days in a week?
The whole week.
The whole week? Good. Okay. So Kaushiki or Vedansh goes. Oh, Kaushiki goes to school. Vedansh doesn't. So the school is, let us say, how much is the school from your place? Any idea?
It's actually quite near. I'd say 3 to 4 kilometers.
3 to 4 kilometers. Okay, let us say 4 kilometers. Let us convert it into meters. Let us say, for example, it is 100 meters away or 50 meters away or 5 kilometers away. So the total distance is 100 kilometers or 50 kilometers, depending on which track you are taking. There must be more than one way of Kaushiki to be reaching her school. Total distance and whatever time Kaushiki takes to go to that school, she might be traveling slowly at first. She might get red signals, red lights in between. You might stop. You might stop for a cup of, well, don't drink coffee. Maybe she'll stop for a ice cream in between, maybe a pizza shop somewhere. You can stop, you can again go, you can again stop, again go faster, go slower. What matters is how much distance you have traveled, total distance, and you divide it by total time, and voila, what do you get? The thing that you get is known as your average speed. Do we understand this? Total distance divided by total time, and I will denote it by this symbol. This symbol, that dabba, means average, and V means speed. So you will say, sir, why V for speed? Why not S for speed? Let's use V for speed. Do you understand this? Total distance divided by total time, Kaushiki, Ayush, Vedansh.
Yes, sir.
Yeah.
That is average speed. The second type of speed is sometimes known as instantaneous speed. Now, Kaushiki will tell us what do you mean by instantaneous. Or Vedansh will tell us. Yes, Kaushiki is telling us. Yes.
So the speed of an object at a particular point in time. So just what's your speed at 2 seconds when you start traveling?
Did you know about this term, instantaneous speed, Kaushiki?
When I was in India last year, I used to look at Khan Academy because I was not at school. So from there.
Correct. Instantaneous. The meaning of the word instantaneous is at this moment, at this time, right now, at 5 o'clock, at 2 p.m., at 5 seconds, after 3 hours. That moment. Instant means moment. Instantaneous means your speed at any moment or any instant. Are you getting me, everyone? Speed at any instant or moment of time is known as instantaneous speed. Now, how do you find this instantaneous speed, Vedansh? Suppose you are on a bike. A bike is not safe. Suppose you are in a car. How do you know your instantaneous speed? Or you are on a bus? or you are on a train, or you are on a plane, or you are just walking. Walking, it might be difficult. Yes, how do you know your instantaneous speed? Anyone?
You look at the speedometer.
You look at the speedometer. What is that speedometer? How does it look?
It's like it's a circle with an arrow.
Yes, speedometer. You look at the speedometer of your vehicle. Speedometer gives you your instantaneous speed. Vedansh, do you know what is the speedometer?
Yes, sir.
कैसा होता है?
Sir, it denotes speed 20, 40 लिखा रहता है उसमें.
हाँ, 20-40 इस पे लिखा रहता है. आयुष, do you know speedometer? Yes, वो जो बाइक पे इतना बड़ा सा गोला लगा होता है, 2 गोले होते हैं कभी कभी. The 2 golas, one gola is for your RPM, revolution per minute. It is calculating the revolution per minute of your engine or your wheel depending on how it is calibrated. One is RPM, कितने RPM जाना चाहिए. बहुत तेज स्पीड करोगे तो RPM बढ़ जाता है. That one is RPM meter. The other one, which has kilometer per hour or meter, it's not meter per second. In India, it's kilometer per hour. In US, probably it's miles per hour. सिंगापुर में क्या है? कौशिकी, miles per hour or kilometer per hour?
Kilometers.
Kilometers per hour. That is your speedometer. As soon as you raise it up, you put on the accelerator, it will shoot up. Shoot! Your speed has increased. Now, whenever you use the term speed, oops, wrong color. Whenever you use the term speed, for example, I ask, Vedansh, what is your speed? Vedansh will just say, my speed is 40 km per hour. Kaushik is also going in a bus. I ask Kaushiki, what is your speed? She'll say 30 kilometers per hour. Same with Ayush. Ayush, what is your speed? She'll say, sir, I'm resting. My speed is 0. Now, whenever we vaguely use the term speed, asking speed, telling speed, talking about speed, which speed are we talking about invariably? Without using the full name, which speed are we talking about? Are we talking about average speed or are we talking about instantaneous speed? Whenever we're talking about speed in general, we are talking about our instantaneous speed. Do we understand this? So in general, when I tell you my speed is 30 km per hour, which speed I am referring to?
Instantaneous.
I am referring to my instantaneous speed. Normally, whenever we talk about average speed, we always use the full term. My average speed is 30 km per hour. When I say my speed is 30 km per hour, more often or not, I am referring to which speed? Instantaneous speed. So these are the 2 types of speed that we have learned today. 2 more are left, which we shall do in the next class. Next class means Saturday. Or if possible, I'll take a class before that also. What are the other 2 types of speed that we'll discuss? Vedansh or Ayush? 2 are done, 2 are left. What are the other 2 types that are left?
Uniform and non-uniform.
Uniform and non-uniform. So that is the task. It's there in your sheet. I can see it. The sheet is right in front of me. So go and see what is uniform speed, what is non-uniform speed. I hope all of you know this. To know this, you can write it. What is uniform speed? Okay, read it. We'll discuss this uniform speed and non-uniform speed and velocity in the next class. We'll try to wind up with speed so that we can move on to acceleration. That's it from my end for today. If you have any doubts, you can ask. Else, this class stands over. Class stands dismissed from my end. Stay happy, stay safe. Even if you're going to school, Kaushiki, keep distance. I hope you're wearing masks. So, stay safe. Take care. Bye-bye.
Bye. Thank you.